あ。はい。So welcome to the competition named WRS Future Convenience Store Convenience Store Challenge. This competition will start from 3 p.m. This is the final day, and after today's task, the champion will be determined of this competition. I am the organizer, one of the organizers, Tetsunari Namura from Tamagawa University, Japan. Okay, so today is the second day, second task named Future Convenience Store Visually Designed, and all the participants will make a presentation. What kind of the future service will be realized using the technology, not only the robotic technology, but also using the cyber technology like a simulation, virtual reality, or digital twin technologies. Then what kind of the more interactive, more friendly, and more natural service robot could be worked in the convenience store, future convenience store. This is the evaluation target. So we have three participants, three teams. Today from 3 p.m., each team will make a short presentation, not short, 15 minutes presentation using not only slide presentation but also the demonstration using the virtual reality devices. Then three referees evaluate the novelty or academic point or usability or interactivity and so on. Okay. So we'd like to, starting from the presentation, we'd like to introduce several referees. From the left, Wada Sensei from Tokyo Metropolitan University, who is organizing the Future Convenience Store Challenge in the real field. And the second, Ohara Sensei from Meijō University. He is also one of the organizers of Future Convenience Store Challenge in real field. And the left side is the Dr. Domai at the AIST, and who is engaged on the digital twin systems for convenience store environment to bridging between the real convenience store and the virtual digital twin convenience store. Okay. Hi. So then almost the time. Then we'd like to introduce the three teams. The first team is unusual. First team is Kyushu Institute of Technology. The team name is Tam Home. This is the first presenter. And the second presenter is from Osaka Institute of Technology. The team name is Triangulars. Okay? And the third participant is from Tamagawa University. Team name is Eraser. Okay. So, then 1 minute to go for the presentation time. So the Kyushu Institute of Technology, Tam Home, is it ready? Okay, so 40 seconds later, you can start. Hi, 10 seconds to go. 5, 4, 3, 2, 1. Hi, please start.
Hi. Hello, we are Tan Hong from Kyushu Institute of Technology. So we will show you our future convenience store vision, which is an interaction through open-ended questions. So first of all, I want to introduce our team. So we are a sub-team from Tan Hong is something of Hibiki no Musashi at home, and this team is continuously attending a competition through the development of home service robots. The competition is such as World Robot Summit and Robot Cup. And we have many robots, like a Toyota human support robot, and the robot is over there. And we will also do a demonstration tomorrow at that exhibition area. And we are developing this kind of restaurant system and other systems which including interaction with humans and manipulation intended tasks. We also develop robot. We assemble parts to develop a home service robot. And another one is a simulator. We have several types of simulator, which is for HSR simulator. This is the same API with physical HS robot, and we can simulate our manipulation skills mainly using this simulator. And from this year, we also attend Sigma's version of simulation week, and this is much focused on interaction with humans. Like the human will ask some instruction using natural language, and the robot has to understand to complete a task. So, I want to focus on and explain about our restaurant system. And in this task, especially in the RoboCup competition, the robot goes to an unknown area, and the robot has to serve some food or ask some orders, for example. And the important point is the robot has to understand the order spoken from humans. So the natural language processing and listening ability of the robot is very important. And our robot can, for example, as a function of our robot, the robot can recommend some items to the customers. For example, oh, our restaurant have a special salad, or this steak is very nice. And this kind of function the robot has. And our robot will pick up items from the counters and serve to the human. So this is details of our task understanding system. So first of all, the robot will understand what the human says using Whisper. This is from OpenAI, and this is very common voice recognition system. And after that, we will give this instruction to a GPT-based system to understand tasks. And this is an example prompt. And the highlight of this system is we break down some tasks to sub-tasks. For example, in a restaurant task, we have some delivery, cleaning up, and conversation. And from these sub-tasks, the robot will choose the appropriate task according to the human instructions. For example, if human says, oh, what is the recommendation of this store, and then the robot will choose this one and listen to the human's instructions and make a response, appropriate response using GPT. So based on this, our system, I will show you two types of demonstration. So before that, I want to explain the current Sigma system for convenience store challenge. So in this competition, the robot will ask, the human will order one item to the robot, and the robot will understand which item is ordered through the yes/no question, closed-ended question, and the human will just answer yes or no. And this is very important for physical robots as well. The robot usually suggest some things or have to confirm the robot is correct or not. And this kind of yes/no question is very important. And however, the human may ask some recommendations. For example, what is the recommendation of the store, or the human may want to tell more than yes and no, like I need blue one, or that is similar but it's not correct, for example. And so, in our demonstration, we suggest a recommendation icon, and we also, the robot can understand multiple instructions. So in the convenience store task, it's just only yes and no and only one item, but we will show you multiple object selection. So anyway, I want to start a demonstration. So in the first demonstration, this is a live demonstration, we will type, please give me a drink which is mashed potato chips. So we are trying to type this instruction, and we will send this instruction to the robot using GPT-based AI system. And we just send this open-end questions, and this is the answer from the robot. I recommend Suntory Lemon 600 milliliter. It's green tea with a deep flavor, blah blah blah. But he says, I want a sparkling drink. And okay, so then robot says, how about refreshing Coca-Cola? So the robot suggests sparkling one. And he says, oh, it's very nice. And the robot will go into location of the Coke and picks up 300 milliliters of Coke. So this is a demonstration of recommendation system. So I would like to ask one of our referee to have a conversation with a robot. So could you ask something to the robot? He will type instead of me. We have menu here. Okay, I'd like to have something to eat. Okay, something to eat. So in the actual competition, we have more than 150 items here, and we pick up some food items, and the robot will suggest you some excellent food. Okay, in that case, I recommend butter cookie. Okay. Okay, so please just type okay. In this case, just push yes. So he will pick butter cookie for you. Then successfully deliver butter cookie. So let's move to the next demonstration. So in this demonstration, the robot just deliver only one item at once. But in the next demonstration, the robot will give multiple items. And we have actually many items in this store, and the human will ask, I want to buy Mount Kinoko, Kinoko no Yama in Japan, and Umaigo, and chewing gum. And actually, in this store, we have many flavors of chewing gums. And let's see what type of chewing gum will be chosen from the robot. So now we are trying to launch simulator. Okay, so this case the customer already asked to the robot, and the robot is trying to generate answer text. You ordered kinoko, umaibo, cheese, and kishito peach 1000, and this is the item name in the simulator, and this is correct. So just push yes button. So the robot will pick up 3 items to the basket. So first of all, the robot will pick up kinoko no yama, Mount Kinoko, and successfully gives kinoko to the basket. Yes, and then we'll try to correct another item as well. And the next is umaibo's cheese. So by doing this, the customer do not have to find items in a store. So this is our future vision. So if we have this kind of robot in a store, the human may just come to the entrance of the store and just say, oh, I want to buy kinoko, umaibo, and chewing gum. And just waiting, the robot is doing this task. So this is our future vision. And the last one is Kisito, and this peach flavor is chosen using a recommendation system we just showed you before, and successfully delivers 3 items and complete this task. So in our demonstration, we first we show you our activities, and especially the command understanding system is very important. So in this demonstration, it's mainly focused on conversation, but in our physical robot system, the robot can do many types of the behaviors. So by integrating our physical system to the simulator, we can do much more experiments using this simulator. And the situation and the environment is always same using this simulator, and we can also repeat same instruction or same conversation from using a log. So we can evaluate our system using just same environment, and this is a very different point from the physical robot system. So we consider both developing physical robot system and simulator is very important to develop our robot systems. And in this demonstration, we have a conversation using open-ended questions. And actually, the original system has no open-ended question system, so we integrate this newer feature for this demonstration. And the robot serves multiple items at once, so this is also a new point of this demonstration from our team. So this is the end of my presentation. Thank you very much.
Okay, thank you for the presentation. Then we are now going to the Q&A session. Hi. Please make some question discussion.
Okay, so thank you very much for your good presentation. So I have a simple question. So why don't you use voice recognition to input the command from the user?
Thank you very much for your question. So um, this is much accurate, I think, because voice recognition sometimes it has some misrecognition. So for the simulator, the accuracy is very important, I think. And we can also use this given environment to extend yes/no question to the open question. So this is our first step to do experiment. So maybe in the next step we'll be using voice recognition or using VR system to interact with the robot. So this is our future plan to use this simulator.
Okay, thank you.
Well, thank you for your presentation. And in the demonstration, did you use GPT-4?
Yes.
Okay, so normally GPT-4 doesn't have the knowledge about the local items. So how did you bridge the gap?
We give a list of items, and the given items is categorized. Like this is beverage, this is snacks, this is chewing gums, and we categorize some items and pick up appropriate items to the GPT. So we have actually several steps to identify object for 180 objects. So this is our strategy to give local knowledge to the GPT system.
Thank you. So for the training, how much cost do you need?
It's just preparing for a list, and that is only for the preparation. So maybe just 30 minutes or 1 hour to prepare a list.
Okay, thank you.
Thank you very much.
Okay, thank you very much for presentation. So, my question is about the service. The proposed service is, as you said, in the future. So, in the front of the store, the customer just order, and then the robot picks up the items. Yeah, it's interesting. But there are many customers. So, I think it's make a great long run. So, how will you solve this?
So maybe having multiple robots is one of the solutions. So in a rural area, we have not much customers, but in the urban areas, we have many customers. So maybe we need more robots, I think.
You really introduce the many robots in the store.
So yes, so we have some choice. So the customers who want to interact with robots, or the customers do not want to walk around the shop, maybe they will ask for the robot. And the customer who knows well about the stores, or they have enough time, maybe they can walk around the convenience store. So this is our vision, because if we customize the convenience store just for the robot, it may be not friendly for humans. So our robot can work in a home environment, and they can also work in stores, restaurants, I think. So this is very good point to just put a robot in a convenience store, current convenience store, and serves and works like human shop humans.
Okay, thank you.
Short question. We can receive a short question.
Do you have any other ideas to use this robot and systems for the convenience store service?
Okay, so convenience store has an eat-in space. So this is one of our proposal, because we have a restaurant system. So just the customer is waiting at the eat-in space and order some items. This is our future plan of eat-in space.
Okay, so it's a time to stop the presentation. Thank you for the first team, Tom Home from Kyushu Institute of Technology. Hi. Just follow from my organizers for the paired evaluation. first team showing some conversation system. Please connect the second team to start. Select the yes or no button to make a conversation. But that kind of interactive system is designed by organizers and then provided to each participant. So that task, interactive, interactive customer service task, that was held in yesterday. We have already conducted as a regular task. So it is provided by organizer. This is the important point for the evaluation. Okay, this is just for information from my side. Okay, so then the next team is team named Triangulars from Osaka Institute of Technology. This is the second team. So if the connection is ready,
Just the speed is not working. So can you just check, please? Okay. まあ、俺それすみませんお願いします。
はい、じゃあ please start.
Hello, hello. Good morning. I'm Ashutosh Mishra. I'm from Osaka Institute of Technology, and I'm so sorry for that. and I'll be presenting forward our Team Triangle's idea of what on how to make the future convenience stores even more convenient. Thanks so much. Now, just a bit about myself. I'm from Osaka Institute of Technology, and I'm studying robotics and design engineering. And my research focus is particularly in virtual agents and AI. Plus, I've been working in a convenience store for more than 2 years now, so I know how it works inside and out. And so, yeah, I can talk multiple languages. So if anyone has anything to ask me, like English and Japanese, like whatever, just ask me, please. Thank you so much. Now, the problems that I'll be showing forward to you has been observed by me firsthand. So, and the problems I'll be developing have been researched, like why, where, and how you can use it have been researched properly. And I'll be focusing on the scalability and the cheapness, like how to make it really cheap. So, some problems that were directly observed by me and my peers in the convenience store is that during the peak times, like morning, lunch, and evenings, 7:30, 12:30, or 5 o'clock, that the convenience stores gets crowded because, everyone is going to work, everyone is eating lunch, or everyone is just going back. So to combat it, and just to talk to the customers, right? Sometimes the customers would ask, I'm so sorry. Could you tell me where is Osaka Station? I'm so sorry. Do you have toilets? Just for that questions, we can just for the guidance, we have to answer to the customers, right? Because customer is king, customer first service. So what it happens is that because the staff have so much work to do, that just because of customer flow, just because of advertising of sales and campaigns, we have karage, would you like some? Would you like some? And also simple workflow shortage. There are not enough people in the store that a staff is overwhelmed, right? So the answer is simple, right? Just increase the staff. Like, what's wrong with it? I mean, that's true, but there is a problem that it's true, it's heavy but true. In Japan, the working population is decreasing because of the decreasing population. That's correct. So let's not look into the human side. Let's go into the virtual side of it. So I will be I on behalf of my team would be suggesting implementing a virtual agent, right? And the virtual agent basically it's just a human in a screen, like an AI. And if you have played Halo, it's like Cortana from Halo, or Siri with a face. Now, a virtual agent can take over some tasks that the menial tasks that human have to do, like general guidance, learning about the customers' preferences. Like this guy, Mr. Tanaka, comes in the morning every time and gets onigiri and mugicha. So the agent will remember onigiri and mugicha, and that is important. Let's keep that in mind, okay? And also general guidance. You can ask the agent, "I'm so sorry. Do you have toilets? Yeah, the toilets is right over there." Simple, right? And also staff support, not just customers. The agent is basically a screen, right? So it has space for advertisements, campaigns, and it can do the customers like the customer services by itself. So that's no big issue. And it can also recommend purpose to the customers. Recommending, that's the biggest thing right now, okay? So, and also the agents can be used like facial agents, because it has an enhanced level of face-to-face interaction with the customers, right? Why? I'll show you. So, in a 2017 study by Harvard Business Journal, done by Vanessa Bones of Cornell University, it was found out that the face-to-face request is 34 times more successful than an email, or in this case, the study actually says a text-based talking. Why? Because human beings, we tend to trust, like to people who face, you can see, like if I see this guy, I can trust him, but I cannot trust him over the phone. That's just the human nature. That's what the study was all about. Now, an agent with a face can emulate a similar level of trust, right? And we are going to be leveraging that to our advantage. The agent is more accessible, it's more convenient, because it's just a screen. It can be placed anywhere in the convenience system, and it will be of no hindrance to the customer. I can walk straight, the agent is there, I can still walk straight. That's no issue. And the agent is, since it's basically a screen, right, it can be scaled easily, because like implementing a robot would be like 4,000, 5,000 American dollars. But the screen is like how much? In yen, that's like 500, 200 yen? So $500, right? And so it's really cheap. And because you have to train staff, right? Training staff usually takes 2 weeks, 1 week. But an agent is just, it's just installation time. The implementation is way faster. So you can get a effectively new staff member in like 6 hours. Now, going on to our suggestion, virtual agent boot. Because of the mechanical implementation, and because this PC is not that powerful to run a machine learning sequence locally, we have recorded the machine learning sequence, and I will show it to you. Here, I would like to you guys to look at it once, and then I'll explain it to you. Please, onegaishimasu.
それはいいですね。その商品と一緒にこの商品も人気です。いかがでしょうか。ありがとうございます。
So, a very simple video. A guy was walking by with a can of energy drink in front of the virtual agent. The agent in the green caught that item, and it just recommended, how about a can of chips with it? And the guy was like, let's do it. He also gets a can of chips, and the agents at the end in the blue box just recorded the guy and just took his face and just remembered it, and let's just put a pin in that, and now just look at it again, and now you can understand.
それはいいです
Green
ね。
box,
その商
the
品
drink.
と一緒にこの商品も人気
Chips
です。い
recommended,
かがでしょうか。
red box,
ありが
the
と
chips.
うございます。
The face, blue box, and that's it. Simple as that. Like 10 seconds, that's it. Now, the possible areas covered by the agent, like it cannot, like as I said, it can promote campaigns, recommended discount items, like convenience stores, when they have to throw an item, just because 1 hour or 2 hours before, they put on a discount. They put on like extra points on that. And because the agent is basically a software, the software has infinite stamina. It doesn't need to break every 5 or 6 hours. so it can work 24/7 and with the same energy as the agent. Like, I get tired, okay, but the agent does not. Now it's an effective reduction of labor costs, to be precise, because it's because the first agent has some money involved, but in the long run, it would be way cheaper than getting a new person, a new hire, and again, it's scalable easily. Also, in conversation, like the agent, we can just it can be implemented to further to infinity, right? And it can also we can also put some translation features in it, like conversation features in it. I can ask him, excuse me, and the agent will say, yes, what is it? I can say, hi, sumimasen, and the agent will go, hi, those like any languages that the agent can adapt to the customers, right? So that would take off the language barrier that the convenience store have. You don't have to struggle to communicate like onigiri like that in hand, but you can just say it. And it can also give personalized service like guidance to you. I can just go into convenience store and the guy and the convenience store and the agent can just see my face and it remembers, hey, you went to the station, right? And let's just put a pin in that. We'll just get back to it later. And it can also give us payment assistance. Like like everyone has heard of the new Amazon Grab and Go stores, right? Like just put an agent in that. Like it's way smoother. And also in the end, like the advertisement, like new items will be recommended, like sales for promotions, 24/7 availability. That's what it said, right? And also in operations and sales, like staff member assistance, that's really helpful. And as I said, practically infinite scalability. Like as long as you have screens, as long as you have a single computer, you can just get like in Japanese terms, that's like 200,000 yen for the whole system. And that's like just pay it once and you have an agent in a store. Just put a screen in it, you have 2 agents. Put another screen, 3 agents. Instead of just hiring someone. And again, auto payment system. I can just go in the store and everything would be like, my payment would be like phoneless, walletless, cashless, cardless, just automatic transaction. If we just get back to the auto payment, right? It's simple. The customer would just come in the store, take an item, and a leave. And the agent, it would it would take an item and link it to the payment portal, add it in the virtual card, and the amount can be charged. That's the customer. That's me. Happy. But let's get back to the training. Like as I said, like it does not require any training. That's like with a bit of asterisk. It's a bit different. An agent does require training, but at the back end, it can be updated all the time, like hot fixes, hot patches. So, based on the personal history of customers, like this guy was there, he was at the station. The agent remembers, and the agent knows. Like next time, if he has to go to the station, the agent knows where he has to go. So first time, I can just ask, "Excuse me, do you know where Osaka station is?" And just like another source, 10 kilometers away. Do you know where the station is? And the agent knows, yep, Osaka station, right? So it will just tell the way. And based on the combinations purchased, like as I said, with the can of energy drinks and the chips, there are infinite combinations, coffee and cookies, onigiri and matcha. Like there are infinite combinations. The agents can just learn and give it to you. Like it can just learn on your combinations, and next time it can suggest the same combination to someone. Supposedly, if sir has kind of chips, the agent can give him drinks, right? And the agents will know the combination, effectively increasing the sales, like increasing profits, right? And also, as I said, personalized guidance across multiple stores. So I can just guide the same person, like in convenience store A and convenience store B. The agent can guide them all the way. So basically, it's a friend that's in every convenience store. Now let's summarize the whole thing. like like getting an agent enhances customer interaction and trust through face-to-face communication, and it's more effective than text-based interaction. And customers can trust the judgment of the agents further because it has a face. And right, and virtual agents can recommend products simply because that's what they're programmed to do. It's in front of them. And real-time translation using API, there are thousands of them. Really, like DeepL is free for students. You can just use them. And facial identification for auto payment, allowing for faster customer. So you can just grab and go. That's it.
1 minute to stop.
I'm almost done. Thanks so much. And it's an effective support to the staff. Like it can do continuous service without breaks, and it can reduce pressure on staff. You know, just like less like a store that requires 5 staffs, like 5 people, can be operated by 2 people and an agent. And that's effectively just coming into the convenience store, and going out of the convenience store way faster. It's basically making the convenience stores more convenient. And that's it for my side. And if you have any questions, I'll address it to now. Thanks so much.
Hi. Okay, thanks. Yeah, let's go to the Q&A session. Hi. Okay, please.
Thank you for your presentation.
Thanks so much.
So shouldn't the agent be provided as an appli?
As an application, it will be too heavy to run on because it has an active machine learning algorithm. If you can just you can cut it down with the machine learning algorithm, but it would be connected to the server all the time. So you can use that as well. That's possible. Like you have the convenience stores app, right? You can just put an agent into it. That's possible. Yes. In this time, it's but my focus here was if I even forgot my phone, I can still buy something. If I forgot my wallet, I could buy something.
Okay, so how do you think about the percentage of the store clerk's works? I mean, what percentage of the store clerk's task can this agent actually cover?
I'm sorry, could you just repeat it for me?
So, I mean, yeah, most of the tasks of the store clerk's job involves physical tasks. So, I guess the percentage of the store clerk's task can be covered by your proposed idea. Is not so big. How do you think about it?
Yes. It cannot there is some task like putting out the shopping items in the aisle, right? It cannot cover them all the time because it's not a physical object. It's basically a piece of software. But with the guidance skills and the audit and the cashless payments, because everyone just goes to convenience store sometimes and asks, "I'm sorry, do you know where the nearest station is?" Like soft stuff. It's not a replacement per se. It's basically assisting the staff so that the store requires less and less people. So based on the percentage, I would say about half, because checking out cashier stuff that can be done by the agent. But to be honest, putting the items in the shelf cannot be achieved by software. I mean yet. So I think that's your answer.
Okay, thank you.
Okay, thank you very much for your presentation. So I can understand your motivation and the problem setting. So I have a simple question. So I just want to know the technical difficulties to realize your system because I cannot find any detailed developed system in your presentation. So if possible, so please tell me please introduce your detailed system, implemented system of your presentation.
I'm sorry, could you just repeat the first part of the question, the first half again?
But I have just one question. So please show us the detailed system in your presentation.
Are you talking of the software? It's made in like Unreal Engine. Like I don't have it on a PC right now.
So what kind of technology do you use or something like that? So
I'm using Unreal Engine 5.2 to be precise. I'm using the same engine. It's made for games, but it can be used anywhere. It's Unreal Engine 2. It can be done on like really small machines, so it's not that expensive. And and the technology, like I don't think I have a screenshot right now. I'm so sorry for that. Uh, it's Unreal Engine, so I think it's like the same platform as where people play Fortnite. So the same story, can just get it. It's an Unreal Engine, and the coding is really simple. You don't even need to program. It's just like like spaghetti, like spaghetti-based coding and all that. You can just pull and make lines. That's the simple programming that you can do in this thing.
One short question.
Thank you very much. My short question. So, you propose a virtual agent in the convenience store. Where will you introduce in the convenience store?
Like
For
as
example, yeah, entrance or cashier place or where?
like based on personal preference, I would say like in the second aisle. But to be honest, it can be placed anywhere in the store. It's like as I said before, you can just have one screen, two screen, three screen. It's basically the same agent in the back end because there's only one computer and multiple screens. So like that question is preference. That is preference.
I thank you for your presentation. The time is over. Thank you for again for the triangles from Osaka Technology Institute of Technology. Okay, the last team is from Tamago University. The team name is Eraser. So please make a preparation for the presentation. So if you are ready, please tell us. So if the connection is ready, we'd like to start the presentation, right? So the connection of the display is ready. We should start the presentation. Is it okay? Hi, please start the presentation.
Okay, so I will start the presentation. My name is Arthur Sakamaki from Graduate School of Brain Science at Tamaga University. Okay, so today I will talk about digital twinning twinning of convenience stores for facilitating human-robot interaction. Okay, so it's introduction, and these days many robots working on convenience stores, but this type of robot only replace human tasks like the delivering the object, displaying the displaying the displaying the object, and cleaning the bathroom, cleaning the bathroom and display many products and so on. These robots still some way to go before they become widespread, but they are becoming more realistic. Okay, so let's thinking about more and more future convenience store situation. It may happen that sometimes people who looking for the product and ask to the robot where they can get the object. But robot doesn't know about ended and happen failure communication between customer and robot clerk. Problem here is how to bridge actual scene and robot cognition. Grounding such information is quite important for the advanced information such as GPT-based interaction and so on. And how future convenience store resolve these problems. In this time, we propose the VR-based application system. Okay. In this system, the third person mediates between customer and robot in the virtual spaces. To be more specific, the mediator logging into the virtual system and give interaction to the robot to assist the customer with interactive method like the pointing target object and navigate to the here and delivery product to the specific position. And this time our team prepare for the live demonstration. Okay, so I will introduce today's demo scenario. And first, a customer requests robot clerk to bring item, but the robot cannot identify which item to bring to the customer. And so the robot asks to the third-person mediator to help the cyberspaces. And the robot recognizes object in the real space and reflect it to the cyberspaces. And the mediator in the virtual system indicate the target object to the robot. Okay, so here is the here is the convenience store environment in our university, and he is the mediator to interact with robot. So this is mediator, and he logging as a virtual system, and now he pointing the location of the. Okay. Yeah, now he teach the robot to move the robot that position, and as you can see, the robot, real robot working on here. And after that, the mediator help the people which items the robot have to take, and this time the mediator the customer order this yellow master bottle, and mediator teach the robot bring this bottle. じゃあ物体を取ってください。Yeah, now moving to the in front of the table, and as you can see, it's this virtual system and the real environment are synchronized. もうちょっと回転した方がいいかもしれない。And as you can see, the robot recognizes the item. And he interacts with the object. Yeah, but rotation is unmatched with. Okay, so robot get the item in the real spaces. And after that, the mediator interacts with the operator the robot to bring the item to the basket. The real robot is now moving and deposit the customer's item to the basket. Okay, so there are many times the moderator interact with the customer order the next item to the moderator. 次のアイテム大丈夫ですか 何が返ってこない？ OK。あ、リンゴ動いてる。Then now the shop clerk change the position when the display is changed. And if the robot doesn't know the knowledge about the position changes, the robot asks to the moderator to help this scenario. And the moderator teach the robot to the correct position of the next item. And the moderator teach the robot the correct position of the apple. 移動しなそう。This time we use the object recognition in the real time, in the real space in the real time, and the robot send the object position and robot location to this cyber system. Yeah. We use this camera from the Then the robot recognizes the object and 出てこない。もうちょっと近づいた方がいいかも前に。So this time we use the mobile network, so there is a many lags. 落ちた。もう一回スタートする。Okay, so it take a long time to take a second object. So, so in this way, the robot can detect and grasp and deliver to the correct object, first object, and they give it to the customer. So, so its conclusion. In this time, we present a prototype system for the prototype system and demonstrate that mediate the intervision in the robot's cognitive space and facilitate human-robot interaction in this like a complex scenario. And this contribution of our work is integration of cloud-based VR system for the HRI and digital twin system. And second one is demonstration of real-time recognized and reflection of real space to the cyberspace. Okay, so let's continue the demonstration. and the modulator operate to the second. 回転させないとダメじゃないか。もうちょっとかな。ぶつかった。Okay, so there are many tasks. There are many problems in this problem. Okay, so it's a network problem, and this time we only communication, only a robot position. We send the data. The data we send is the robot position and objection. So there, next time we have to change the position of the wall. We need more information for reflect to the cyberspace environment. めり込んじゃって。In real space, there are no collision in the robot. Okay, so that's our presentation. Thank you.
Okay, is it okay to finalize your presentation? Okay, then let's go ahead to the Q&A session.
So thank you for your presentation. So what are merits of using virtual space instead of using actual field for the interaction?
Okay, so for in the future, maybe there is no person in the convenience store, but sometimes maybe the robot cannot communicate with the person, and if they update the environment of the convenience store, robot have to know the environment. So if occur this situation, the modulator log into the robot cognitive system, and they interact with robot and update the problem is enabled.
Yeah, I understand. But now we are using Sigbus, but if customer can understand the actual field by using the camera or camera mounted on the robot, we can instruct instead of using the simulation. So how do you think about the merit of using the
interaction between? Okay, so this is in my opinion. It is difficult in the real space to interact with the robot to like the pointing, go to the here and give that item is difficult in the real space, but we can use the VR system. As you can see there, the very easy to interact with, like the VR people pointing, and you can say let beam is the let beam.
So easy to interact.
Easy to interact and
That's interesting. And is it possible for the real robot to avoid the other customers?
Yes, of course.
Oh, great.
Yeah. As you can see, the robot have a map and robot avoid the other person in this system. Yes, robot recognize the environment using the laser-based system and depth camera used for the avoid other person in this system.
Okay, thank you. Yeah, nice system.
Oh, okay, thank you very much for your very interesting and challenging demonstration. So, I think your trial is one of the important feasible study how to apply the digital twin technology to such service robot system in convenience store. So I want to know what is the most important point to solve to realize such kind of service.
Realize the service. Okay, so you mean the how to robot? Okay, so your question is how to.
So maybe there are many difficult points. So what is the most important point do you think to realize such kind of service in?
Okay, maybe in my opinion, the interaction with human and robot is very important, I think. But there is many, but I think there are many misunderstanding between human and robot. So I think the mediator or moderator interrupt that communication and update the information to the robot is one of the important situation in this convenience store system.
Okay, thank you very much. So in your demonstration, so you just recognize the unknown object. Yeah, that is one of the service. I don't know what we can say. It's service. So, but in future convenience, so in your scenario, there are no clerks. Okay, and so therefore that you propose the robot may support the customer. So, but in recognition of the items is one of the important point. But do you have any ideas?
Recognize.
No. To using this system to serve the new services to the customer. Not only recognize the products.
Okay, so. Okay. On this system, we focused on the not recognized object. We focus the interaction between human and the customer, how improve the more convenience. Yeah. So we don't focus on the recognized object this time.
So thank you for the presentation. Then all the three teams have finished the presentation. Thank you for the evaluation. So please input to the Google form for the evaluation, and we will calculate the evaluation score with the result of the yesterday's regular task. So we'd like to have our award ceremony for around 4:30. Okay. Hi. Just thank you again for your great and excellent and interesting presentation. Thank you for your participation.